To continue on a bit, we're going to look at these problems. 9 and 10 are similar to each other in that this time, unlike 8, where it said that the lines that appear to be tangent are actually tangent, these ones, we've got to determine if they are tangent. Okay, so we're actually going to still use the exact same theorem, sorry, blanked on what it was called, where this has to be a 90-degree angle right there. Okay, that's the only way it'll be tangent. So what we're trying to determine is if this, so I'm going to put a question mark here because we don't know if that's 90 degrees, and if this angle right here is 90. If they are, then it's tangent. If they aren't, it's not. Well, if you notice, we've got some nice little triangles right here. And if it's a 90-degree angle, it should be a right triangle, meaning it should follow the Pythagorean theorem of a squared plus b squared equals c squared. Okay, I like to start out with my hypotenuse, so I like to write it this way. So remember, c is the hypotenuse. So we'll go ahead, let's start that out. Let me make that smaller. So we've got 37 squared. I want to see, does that actually equal? So I'm not actually going to put an equal sign. We're trying to determine what this is. What is it? Is it equal, greater than, or less than? Okay, 12 squared plus 35 squared. Okay, well, I'm going to pull out my calculator, and I'm going to determine what 7 squared is. And that is 1,369. Remember, we're trying to determine, is it equal, greater than, or what? What is it? Okay. Then I'm going to go ahead and do 12 squared plus 35 squared. And would you look at that? I get 1,369 as well. So they are equal, which means it's a 90-degree angle. So this is tangent. The line is tangent. Awesome. Okay, so we're going to go ahead and move on to the next one and see if this one is also tangent. Okay, so once again, we're not sure if this is actually a 90-degree angle, so we'll set up our Pythagorean theorem. So we start with the hypotenuse, or what we suspect is the hypotenuse, so the longest side. We're not sure what it is, so I'll put a question mark there. And then we've got 5 squared plus 16 squared. Well, 17 squared, let's figure out what that is. 17 squared is 289. We want to determine, is that equal to 5 squared plus 16 squared? So I'm putting that in, I get 281. So notice they are not equal. In fact, this is greater than. That actually tells us it's an obtuse angle, if you remember, in our last unit. So this is not a tangent line because it will only be tangent if these two numbers right here are equal. Okay. Let's kind of use something similar. Let's continue because the next two are somewhat similar, except that for these two, they are telling us that they are tangent, but we get to use the Pythagorean theorem again because once again, now that we know they are tangent, we know that this forms a right angle. This tangent line right here forms a right angle with this radius. For these problems, they want us to find the radius, and we get to find it to the nearest hundredth, so we don't have to simplify square roots or anything like that. So let me make that smaller. Let's go ahead and start with our hypotenuse, which is 13. Now, if you're looking for a leg, remember there is actually a shortcut to doing this. So I can say 13 squared is equal to my leg squared plus my leg squared. Or I could have just said my leg squared is equal to the hypotenuse squared minus the other leg squared. Okay, let's go ahead and figure out what that is equal to. 13 squared minus 11 squared is 48. So r squared equals 48. Now we're not done because we need r. So we're going to go ahead and take the square root of both sides and we'll find the approximate answer to the hundredths place. So we get the square root of 48 typing that in, is, so this is what my calculator says, the first three, but hundredth, remember, is the second decimal over. So since this 8 is bigger or greater than or equal to 5, our answer should be 6.93 because we round it. All right, let's go to number 12. Same idea, same thing. We're doing all sorts of fun stuff. So for number 12, we do know it's a right triangle. The hypotenuse, now this is a little weird, but the hypotenuse is this whole segment right through here. So the hypotenuse is actually 6 plus r. That's RC. And then these two are the r and the 9 represent the leg. So if I use my Pythagorean theorem, I've got 6 plus r squared is equal to r squared plus 9 squared. Let's start cleaning things up a bit. If you have a binomial that's squared, we do need to split it up into two binomials, and then we have to distribute or FOIL. We've got r squared. 9 squared is the same thing as 81. So now I'm going to go ahead and FOIL. So 6 times 6 is 36. 6 times r is 6r. R times 6 is 6r. And r times r is r squared. And that equals r squared plus 81 still. So let's go ahead and combine like terms on this side, but then also let's rewrite it in standard form. So the r squared should come first. So I've got r squared plus 12r, 6 plus 6 is 12, plus 36 equals r squared plus 81. So we'll go ahead and go from there. We're going to go ahead and let's subtract r squared from both sides. Oh, this one's a fat marker. Well, that actually is nice because then our r squareds are gone. We're left with 12r plus 36 equals 81. Let's make that a little smaller. So then we can subtract 36 from both sides. So 12r is going to equal 45. And then we're going to go ahead and divide. Let me switch color. There we go. Divide both sides by 12. And you end up with r is equal to, well, 45 divided by 12 is actually exactly 3.75. Remember, we have to go to the hundredths, which that is exactly where we're at. So that's your answer.